Hi, I'm Hannah from Love Learning Tutors and I'm running through the GCSE syllabus, the spec. So we're going point by point and we are on 1B, which is atoms. So we're going to talk about separating mixtures. So last video I talked about the difference between things being chemically bonded and things that are mixtures. So if they're mixtures, they're physically put together and they're easier to separate because they're not chemically bonded. So usually, you know, it's much easier. Yeah, it's much easier to separate out mixtures. So these are the ones that you need to know for the exam. So simple distillation is usually for two liquids. Okay. So for example, if we have water and we have ethanol. They're both clear, you can't really see, so how would you actually separate them out? So we know that water has a boiling point of 100 degrees and we know that ethanol has a boiling point of 78 degrees Celsius. So this is something we can use to our advantage. So let's say we put the mixture that we have in a round bottle flask. This is a horrible drawing of fire, right? You've got this lovely connecty bit here. You've got this is my thermometer, so it's going here. And then we've got a tube here, and cooling tube here. So the cooling tube is connected to a water source. So it's got cool water coming in all the time. So this is going to help our product, something like that, condense and gather here. Okay, so for example, which do you think is going to boil first? Is it going to be the ethanol or the water as we're heating this up slowly? It's going to be the ethanol. Reason being, it has a lower boiling point, so it's going to take less heat to be able to make it turn from a liquid to a gas. So as the ethanol boils off, it comes up here, it's still a gas, and as it comes into here it condenses and it turns into a liquid and trickles down over here. And we can read the temperature here, so we know when it's meant to be meant to be boiling, so we know when it's meant to come off. So whatever doesn't come off at that point should be water. So either you can do it in 2 doses if you know you have pure ethanol or water, or you can just remove the ethanol first and then, hey presto, you have water left in your round bottomed flask. That's the name of that. So we have round bottom flask here, we have a thermometer here, and the condensing tube over here. 2 liquids. Okay, fractional distillation, it's the same thing, but instead of having this one temperature, it's far bigger and you have different sections. Sorry, again, horrible drawing, but I hope you get the idea. Where it's the hottest at the bottom, so hottest here, hottest, and it's the coolest up here. So you'll see this with petrochemicals basically. So you put in your crude oil here from the bottom of the sea, and there's a mixture of long and short chains. So the longest chains are the most viscous and have the highest boiling point, so they will come out and collect in the tubes at the bottom. And then the shorter chains are gases and they will condense somewhere up here where the temperature is much cooler. So again, and then the ones in between will be varying. You know, the chains are getting longer and longer and longer as you go down, and they have higher and higher boiling points. So this is again dependent on separating out liquids via its boiling points, but it's got several different channels to come out of. Filtration. So filtration, we've all used a filter before. I'm sure you've done it in your lessons in your classroom. You know, you have a little funnel here and then you have the filter paper. So think about the kind of things that are going to get stuck. If you have sugary water, do you think sugary water is going to get stuck in your filter paper, or is it going to go all the way through? It's going to go all the way through, right? Because sugar is a solute and it dissolves. Because it dissolves in the water, you can't separate it out this way. So this only works if you have a insoluble, so you get, this is called the residue that collects. But in order to be able to collect the residue, or remove the residue from whatever liquid you have, it needs to be insoluble. If it's insoluble, then it will get trapped on the paper. If it's soluble, it will just go through with the rest of your filtrate. Yep, so the terminology here, so you start off with, you know, this is the residue, the stuff that gets caught, and the filtrate is the stuff that goes through. And this only works with a insoluble, solid, and liquid. So, for example, you could do this with muddy water, so then mud will get stuck here. You do it with sand, you know, anything that doesn't dissolve. You can't do it with salt, and you can't do it with sugar. Okay. So crystallization. I always like crystallization. It sounds really nice, but it's not actually altogether that exciting. But hey ho, so you have done a neutralization reaction, for example, and you've created a salt, but your salt is dissolved in water, and you want to get your salt back. You want to see those salt crystals. So first of all, what you're going to do is you're going to this is my fire. You're going to heat it up, okay, and you're going to boil it off to reduce the volume. So then you'll end up with something like, oh, I don't know why the volume of the flask shrank, but let's say you've got that much, right, so it's more concentrated. You can also add a glass rod if you want. It helps crystallization, and you just leave it to cool, and then over time, maybe over a day or two, you come back and there'll be lovely crystals in the bottom. If there's still a lot of liquid, you're welcome to filter it off, and then you can collect your crystals from the filter paper, as they won't be dissolved anymore by this point if you've let them crystallize properly. Last but not least, we have paper chromatography. So the famous example that you might have done in the classroom is doing this with a pen and looking at inks. So what you're doing is you're separating out this mixture. So what you do is on a piece of paper, with a pencil you draw a line. With the inks that you're testing, you draw little blobs. These are called your stationary phases. And then you put this in a special thing you close off like this, right, with water in it, and as the water flows up, you'll notice, you know, some patterns, like, you know, something like that. And the reason why you get the different blobs ending up in different positions is because each of the compounds will travel at a different rate within the liquid, because they'll have different interactions, and this is how you separate these out. So this is quite common, you know, for inks or for food colorings and stuff. So this is, again, I guess it's liquids, but it's not really dependent on boiling point. It's more dependent on how it interacts and how it travels. So yeah, so usually inks, food colorings. Brilliant. And the mobile phase would be the solvent that goes up and travels, brings the ink up with it. It doesn't necessarily have to be water. Thank you so much for watching. Keep your eyes peeled for the next video. Bye.